Hi, nice to see you, Florian, again. Maybe before we get cracking, I think it's interesting for everybody on the call as well to know, especially you, Florian, because you're the star.
Yeah, thank you very much, Wouter. Great to be here on the March Tech Talk. Florian Gessner, I'm CTO of TIS, with TIS for more than 12 years now. Have a background also in SAP engineering, and it's great to be here on the webinar for data architectures. It's an exciting topic, exciting time to be in tech, especially in the context of data, and happy to be part of this webinar today.
So before we get cracking, maybe a short introduction from my end for the people. I am also part of the TIS group, of course. I am responsible for two teams, actually, the professional services and also the product team. So that's why I think we can have a great session, indeed, on data architecture and process resilience. What I want to cover, actually, Florian, just to give you a heads up so you can prepare a little bit, is like, okay, what does it mean, right? I think a lot of people want to have like clarity of what are we going to tackle, looking at architecture specifically, how do you tailor it, challenges, of course, I like those things as well. What are the advantages in the end, and then maybe to finish up with resilience, as it is the second topic of our meeting. So maybe to start it off with, can you maybe explain to the audience, like, what does resilient data architecture actually mean?
Yeah, in general, the resilient architecture, not only limited data, is that you design your system and your organization such as that your data is and your organization is prepared and ensures that it can remain operational and reliable in the event of failures or disruption or cybersecurity threats. So you prepare basically for data loss or events which could cause data loss or could cause damage to data. And with this, you implement measures to ensure that your data is secured and the data integrity is ensured over the whole life cycle of your data. And at the end, with this, you achieve or try to achieve a high availability of your data, with at the same time maintain a great performance, and with this a great user experience. And there are a couple of characteristics. Yeah.
Because performance, right? You mentioned it now, but maybe you're going into details. The performance is also, so first of all, of course, the risk, and it has to be secure, but also performance, right?
Exactly. So they go hand in hand, because a loss of performance also means, to a certain extent at least, a loss of availability, because you might face requests not being processed in time, being delayed, or not being completed at all. So performance drops or performance hit also has an impact on the operational availability and reliability of the processes.
Anything else that is what does it mean? Or, because then of course I have the next question, right? Is like, okay, this is very important, but how do you do this actually? How do you tailor this?
Yeah, I think the main characteristics for data architectures are very similar to other computing architectures, that you have to design your system such as that it is fault tolerant, which means you have to ensure that data is distributed in multiple locations, usually within geographical boundaries. You have to prepare for disasters, so that you have a disaster recovery strategy, which should be aligned with your business continuity planning. And you have to prepare for it. So you have to train it, you have to test it, so that you are prepared for the event of a disaster. And this also means that you have to prepare for scalability, which means you have to foresee a certain data growth, whether it's data growth in volume, velocity, or variety. And you also have to be prepared for spikes, because usually there are spikes within the year or within a month where you have to handle more requests. And this is something your data architecture and your system architecture also has to support, so that you can handle the workloads with the same performance profile as you can handle it with lower traffic. And at the same time, you have to maintain high security and data privacy standards. So you really have to embed security early in the development process to make sure encryption, data access policies, and so on are prepared very early in the development phase, so that you ensure that you implement high standards for data security and privacy, and with this prevent your system from unauthorized access, data breaches, or data leaks.
And a question on this one, is that a layer on top, or is that part of the architecture, the security?
The security is part of the architecture, but it's something, or it should be part of the architecture. Ideally, you build it in a data platform, that there is a layer which allows you to control the data access. Usually in modern data architectures, you use tag-based authorization concepts which allow you to use tags to characterize certain data sets, and they allow you to provide fine-grained data access based on these tags which you have defined earlier in the development process.
Right. Yeah, you mentioned one of the aspects that I think a lot of clients and also, well, companies around the globe face is what is it, a decentralized system landscape, right? It's where multiple ERPs, multiple systems, external, internal. Just a question on this one is that, so let's take a simple example. For example, if you have an SAP machine, right, running, you have multiple SAP instances running, also other solutions or other databases. Does that make it more complex, or is that design? How do you see that design of such a complex decentralized organization?
I would say it's a standard. Yeah, all our companies run multiple systems, multiple ERP systems, treasury systems, human resource systems. There is no company in the world with a single IT system, and that's why your data platform has to support this, that you are able to ingest or load data from various sources into your data platform, that you can clean the data, prepare the data so that you can analyze it efficiently in your data platform. And the platform also should or must give you the flexibility to adapt to future developments. Things constantly change, so your architecture needs to be prepared for changes.
Yeah, it's indeed true. If you look at ERP landscapes these days, I think multiple clients are facing upgrades, migrations, or changing platforms, right? Where we go from an SAP to a Microsoft or vice versa, or S4. So yeah, true. Future state is important. Also, I like the fact as well, and I'm interested as well in clean data, right? It's something you just mentioned, but this is critical, right?
Exactly. So to maintain hygiene of your data, cleaning the data, preparing the data so that they are up to date is critical. So this is the whole topic about data quality management, where you should really have a governance framework in place with policies and standards, defining also roles and responsibilities and certain data quality metrics to ensure that your data sets in your data platform are up to date, fulfill certain consistency and quality standards, that there are no duplicates or inaccuracies. Because the worst case, I personally think, you can have in a data platform is inaccurate data, especially when you think about this in the context of machine learning and artificial intelligence. If you train your models, if you train your AI system based on inaccurate data, this can have a fatal impact to your business. So that's why it's important to maintain these quality standards and to continuously monitor and improve your data. So data quality is a continuous process where you have to have validations in place and where you have to have methodologies in place to ensure that your data is clean and remains clean.
Yeah. Would you say it's a prerequisite, or is it something that you just have to maintain and you have the policies, but you need to have a clear view on your data, right, before you even start designing, correct? Or
it is a prerequisite, because otherwise, independence of machine learning or whether it's analytics, but you will get the wrong insights, you will make wrong decisions if your data is not prepared properly.
Yeah. Well, I think you covered already some of the challenges, right? Challenges are the prerequisite. You need clean data. You need a clear security setup. Are there any other challenges that you see or other risks?
Yeah, sure. So challenges when it comes to data or data platforms in general, cybersecurity risks such as data breaches are critical, and where you have to be prepared as well, where you have to ensure you use high security standards, use encryption end-to-end, use principles such as least privileges to ensure only authorized people have access to the data. Then there are compliance and regulatory requirements. We have the data privacy frameworks such as GDPR, where you have to ensure you stick to the legal requirements, which, for example, limits you where you can store data according to the contractual frameworks. Data residency is a huge topic there, and where you also have to prepare to ensure data can be obfuscated or is obfuscated depending on the user roles and permissions. And here again, having a data strategy and a compliance strategy which allows you to implement such features into the data platform is of huge value, because you don't want to reinvent the wheel with each and every data set which you maintain in your data platform. And then I mentioned it before, outdated or invalid data is as well a huge risk in such a data platform, because of the risk which I mentioned before. You will make wrong decisions, and this is also very hard to figure out if you have a long data pipeline which transforms data through various stages, and if there is a wrong data set or invalid data in an early stage, tracing this, it's very hard. So that's why having this process of data quality management and data hygiene is super important and critical. And when touching the topic of cybersecurity, you also should never underestimate the risk of insider threats. So that means you have to build security into all layers of your organization, and this is goes close hand in hand with the whole system and the whole security procedures you implement through the complete value chain. This also means you need to have processes and procedure in place to restrict who has access to the data, who can implement or deliver processes on top of the data, which again goes hand in hand with processes and procedures such as continuous development and continuous integration.
Okay, so now you scared everybody, right? Because there's quite some that you need to consider, right? You need data hygiene, you need cyber security in general. There are some risks related to it. There are a few advantages. Well, the advantages are speed, right? The performance, of course, also data reliable data, which you want to achieve. But now, if you look at why would you do it, right? What are the advantages? And why would you now, at this time, as a company, say like, look, we need to look at our data, we need to look at our resilience and architecture. What are other advantages, or why would you do this?
Yeah, and maybe to calm down a little bit the risks. I think they are important for data, but they are important in general for any IT system today. And you have to address the operational risks, the reputational risks, compliance risks, financial risks associated with such a platform. But it's something which you have to embed in your organization, and it's important to have this security first mindset implemented. It is crucial for the business. But there are so many advantages, yeah. And it's on the one hand side, having a strong data platform can help you on the one hand side to improve scalability and flexibility. It can help you to improve the operational continuity, but first of all, it will help you to leverage your data. And there is this saying, data is the new gold. To be honest, I disagree with it to a certain extent, because not all data is gold. It is the right data at hand is what is the gold. And but if you have well-structured and well-prepared data, this is the foundation to implement and to leverage improved decision-making capabilities, deep insights, deep learning capabilities, analytics, and AI/ML. It's the foundation, and it's a crucial part. And I think this is also looking forward into the future. This is what will make a key difference between companies and organizations, those who are prepared for it, those who have the data at hand, those who work data-driven, compared to companies who have not this mindset of being data-driven and working with data. And there is also this opportunity to gain increased efficiencies, whether it's in automation or to replace or get assistance with repetitive tasks with tools such as generative AI. And they all can only work with a solid data platform, with well-prepared data. And this is a huge advantage and a huge potential we see for the upcoming years.
So if I can put it in short in one sentence, and you have to tell me if it's correct or not correct, right? But can I make one sentence that says basically the data is the core of all your systems, from your current systems, but also your future system, and is also going beyond looking into AI/ML. Is that a good summary, or you would add something to it?
Yeah, it is. It is absolutely the case. So the data is the core, and it is a key enabler for today's.
It's even better. That's even better. Key enabler. Yeah. Like it. You made it better. Yeah. All right. Hey, very interesting. But also, so now we talked about data architecture, the advantages, what challenges, as we all know. One topic we didn't touch upon is resilience, right? Process resilience. How can we ensure process resilience? What is needed?
So when we talk about process resilience, it's in general that you create systems and workflows that are robust to withstand certain disruptions, and at the same time that they are flexible enough to adapt to certain unexpected situations. And therefore you again have to think about what are certain risks or certain challenges which I need to cover, which I need to foresee in my system, and you have to prepare for it. This is, for example, that you should be prepared for redundancy and failover. So a data center can fail, and you should be prepared that your data platform and your system, that your processes survive a data center failure and that it can operate in another data center. Therefore, for example, we at TIS, we work with AWS. AWS works with different geographical or with different regions, which is a combination of multiple data center. With each region, you have at least 3 data centers combined. Each data center represents an availability zone, and our architecture is prepared for availability center failures, but also the complete loss of an AWS region. So which would mean 3 data centers, for example, in the Frankfurt region are not available any longer, and we have to switch to a different region, such as Paris. And with this, we prepare our platform for the unlikely event of a massive loss of data center capacities in Europe. And this is not only limited to the data centers, you need to implement the same on the business processes, so your servers, your applications also need to be prepared to survive certain outages. And this all, again, goes hand in hand with business continuity planning and disaster recovery. And you have to be prepared for this. You have to test it. You have to have drills. And there are also tools provided to test them. So there are tools such as chaos testing, where you test the loss of a server, loss of an availability zone, and you try with this to harden your system and to make it more and more mature towards failures and infrastructure outages. And then there is a second part, and I think this is something which is not only important for data platforms, it's something which is which should be, from my perspective, a key capability of all cloud platform, and this is automate everything. So you shouldn't start to build infrastructure in the cloud, and it doesn't matter if it's a public cloud such as AWS or if you run your own private cloud, but you shouldn't start to implement anything in your infrastructure manually. Your infrastructure should as well be implemented through code. There is the concept of infrastructure as code, and this allows you to implement the same infrastructure in a different location very fast. It's repetitive, and you can implement the same quality and quality assurance standards as we implement them for software development. You can have for ICE reviews and so on. This allows you as well to recover from failures faster, because you can rebuild your infrastructure from code. And this is for a foundation, and you need to combine this as well with monitoring, alerting, and incident response, so that you have the insights into your processes, understand what's going on in your system 24/7, be alerted so that you can respond fast to failures.
This was brand new for me. I didn't know it literally. I didn't know it existed. Very cool. By the way, I have a question, maybe a little bit of sidetrack of the topic, but you mentioned data recovery, right? Whenever for business continuity or disaster recovery or whatever, right? I have a question maybe, and that's related to from your angle, right? And you're the expert. If you look at a disaster recovery, what is the biggest what has the biggest impact? Is it system recovery, or is it data recovery, or the combination of the two? Because I think some people really think that, okay, if something goes down, it's like, oh my God, my SAP went down, right? This is your system. Or is it, what is the most problematic? Is it the data piece, or is it the system piece?
It is basically, it's a decision, or it depends on the decision a company takes how they want to implement disaster recovery. So if you, there are different strategies for how we can implement disaster recovery. What we, for example, implement within TIS is that we have our primary site where we operate our systems, and we have a disaster recovery site, and we continuously replicate data to the disaster recovery site so that we have our databases, our data always in sync. There is a small time gap between the primary site and the secondary, the disaster recovery site, but we have the data available in at least 2 different geographic region or AWS region within the same geographic region. So with this we avoid, for example, that there is data transfer to the US, which would be critical for European customers, and the other way around as well. So we take care that the data remains in the same geographic region, but we implement their replication between 2 different AWS regions. And with this, our data is available, and we also prepare our infrastructure so that we can scale up our services in the event of an outage of a AWS region in a very limited period of time. But as I mentioned, it really depends, because there are multiple strategies. This is the strategy we've selected. You could also work with backups, but then you might face a larger loss of data in the event of an outage, and you will have more work to recover from it. But it's cheaper, so it depends on how much risk appetite you have and how much you want to invest in your disaster recovery strategy.
True. I'm happy that you mentioned the price, because if you want 0 data loss versus backups, there's a huge price difference, right? It's timing, or the data replication speed is actually the majority of cost, right?
Exactly, cost, and this is also something in general for data platforms. When you're architecturing in the cloud and when architecturing solutions for data, you should always have costs in mind. Training large language models, training AI models is an expensive task. So you should really think about your costs, and also storing large amount of data in the cloud can be very expensive. So you have to architecture your system for costs as well. And there are solutions how you can improve costs, but it's important to have this in mind from the very beginning.
That's a good one, because data retention, right? Data retention can be part of your design, no?
Exactly. And so it's data retention is one topic, but also there are different storage systems. So
what I mean with data retention is not that you have to have the data, you can delete the data. What I mean is just which data do you have actively available in your platform or in your data environment.
Yeah, exactly. And based on this, you can select which storage solution you select. So not all the data needs to be available instantaneously, and you have to store it in a database system. You can also store data in object storages, such as Amazon S3 is a very popular storage solution, where you don't have to pay for computation, where you only pay for the storage, which is a huge difference. And when you want to access data, then you can still access it instantaneously, or you can also put it there into an archive. And then you have different retrieval strategies, and it's different cost structures. And with this, you can optimize your data platform and your storage according to costs, access patterns, and data freshness as needed for the particular use case.
And performance.
And performance, yes, exactly.
Okay, very cool. All right, I don't have any other questions, Florian. Is there something that you that I missed that you still want to share, then please do so. Otherwise, I will leave it over to the people on the line to ask some questions, if there are any.
Yeah, I think there is one more aspect which I think is important for scalable data platforms, and this is something the IT industry already started this journey with microservice architectures, where we started to split large monolithic applications into smaller applications depending on the business domain, and have clear business ownership and also clear understanding in the engineering teams about the business domain. And in the past, we started as well with monolithic architectures in the data field. So the same pattern happened there. We built a data platform team. They orchestrated the whole data platform, or quite often organizations work with a data lake. And there is a similar trend starting in this area. It's called data meshes, where you break down this data silo again, give more responsibilities to the different engineering teams or different departments, so that they can leverage the data within a compliance framework. So you define certain rules and compliance standards, but you have the responsibility again in the different teams, and this helps you again to scale your data platform within an organization. Instead of having one silo which never ever can cover all and understand all the business domains in depth, you spread responsibility, but have a framework around this so that you ensure security and compliance. And I think this is another important aspect for a scalable data platform, because the organization is so important for an architecture that you should never forget it. And it's important that you have clear responsibilities.
And you kept this for last. No, it's really interesting actually, because it ties in with everything, right? Also risk, everything, that like data resilience, but also looking at the quality of the data, because if you have it not in silos, then you have more quality because you understand. Okay, very nice, very interesting. All right, hey, thanks, Florian. Now we are open, I guess, for questions from the audience.
Sure, thank you so much, Florian. That was a really wonderful session. All right, we had two questions, Roland. The first one comes from Mateo. Is a scalable and adaptable data environment a prerequisite for AI?
100%. Yeah. So I think this is the foundation, because you, on the one hand side, you need the data platform, as mentioned before, with the clean data, with the prepared data to support your AI and ML use cases, and at the same time also ensure the data quality. And that's why I fully believe in a data platform, and I fully believe that it's the enabler for AI ML.
Great, thank you so much. And our second and final question comes in from Emily. Is there a difference between data architecture in SaaS solutions and other solutions?
In general, I think it depends on the maturity of the company, the maturity of the IT infrastructure. There are also self-hosted environments where you see a similar quality of IT infrastructure in terms of services and capabilities as certain cloud vendors provide. But I think, especially considering the latest trends, whether it's the large language models and this fast development in artificial intelligence, it's getting harder and harder for organizations to keep or maintain the same quality of infrastructure in your own data center. That's why I think there is a difference, that you can leverage these AI, ML, and data processes much faster on public clouds. But it's also a trend that you see a hybrid model, whether it's a hybrid model between public and private cloud, or a hybrid model between different public clouds where you mix and match which services you want to use to make use of the best capabilities in the market, while at the same time you want to ensure your data is secured, or your data resides in your on-premise data center, and you only want to share a limited amount of data with the public cloud vendors. So these are different trends, but I think it's really difficult to implement this in your on-premise data center, and it's also especially getting access to the hardware, because currently the public cloud vendors they more or less buy all the GPUs to ramp up the data centers for artificial intelligence. So that's another reason. So you might not be able to get the hardware to implement the same quality in your data centers.
Great, thank you, Florian, and audience, thank you for your questions. Florian and Wouter, would it be okay to offer up, if the audience has any questions, they can reach out to you on LinkedIn?
Yeah, sure.
Okay, so sure. If you have any questions, you can reach out to Wouter or Florian via LinkedIn, or you can email us at info@tispayments.com. Thank you again. Wouter, I'll hand the session back to you to close.
Hey, Florian, thanks again. I learned a lot. I think the audience learned a lot as well. Maybe I wanna ask you very shortly, right? And maybe that's something to close it up with. Is you talked about resilience, and just give me 2 more minutes, or I give you 2 more minutes. Resilience business B2C, B2B, right? I got it from if you look at the data setup. Is there differences between the two?
So I think the main difference, or a huge difference, what we see between B2B and B2C is that in B2C, usually customers give their consent to this provider through accepting their terms and conditions, and they have to accept them or they simply can't use the service. And especially in the B2C, you see that unfortunately people don't care too much about the terms and conditions, which is completely different in B2B, where we go through contract negotiations. There are legal departments, and that's why we have a different, and I think it's something positive, we have a much better legal basis for data processing in B2B, because we went through this cycle of contract negotiation and ensuring compliance and agreement on the terms and conditions. And that's, I think, a key difference. And we have to comply and stick to the contractual agreements and the legal requirements. But this gives us as a company, but also to our customers and partners, a solid foundation for implementing a mature data platform. And I think that's super important for sustainable business.
Exactly, I fully agree. All right, I'm sorry, I had to ask you this additional question. Just popped into my head with the last questions we got from the audience. And but anyway, Florian, I want to thank you. It was a brilliant session, and I want to thank everybody on the line for joining us. And well, voilà. See you in the next session in a couple of weeks or months.